Hi everyone, we're back again at Electric Drive Africa, Africa's most trusted platform documenting the transition to electric. And I'm here in Kenya, my home, Nyumbani. I'm here with a good friend of mine, Francis. I've known him a long time. Actually, I know Francis from the solar industry. I've been working in the solar industry for over 10 years now. That's how I met Francis.
Yeah.
And Francis is passionate about renewables, and that saw him transitioning now, obviously, automatically, naturally, into electric mobility. So Francis, good seeing you. Karibu
Good to
to
see you.
Africa.
Pleasure. Good to meet you again after so long.
After so long, yes. So tell us, a lot has happened since we last met. I remember we were doing solar together, but now you're doing EVs, and you're building a whole ecosystem to support this transition. Because a lot of people are worried about a lot of things. One, charging the infrastructure,
Yes.
the vehicles themselves, especially support and backup and maintenance and repairs and availability of skills to handle this whole ecosystem. So tell us how your role and how you are championing this.
Yeah, so yes, we met in the early days in the solar industry, but then we transitioned and we say the energy transition into the transport sector.
Yeah.
So what we've been doing right now is moving away from just solar for solar's sake into designing solar systems that are powering the transport sector.
Okay.
So we deal with charging infrastructure supported by solar systems. We deal with home charging, workplace charging, commercial charging, and also we are bringing in new electric vehicles as we'll be showing you.
Okay.
So we cover the entire industry, and then we realize that there's not enough skills to promote and support electromobility. And so now we are also training. We've put together a battery lab of ourselves, and we are able to train different skills across EV maintenance, battery repair, battery upgrades. We're doing all this stuff.
Okay. Yes. So the number one question I get everywhere I go is like, you are championing electric vehicles in Africa, but we get all these power outages. How are people going to charge? And I see you have this station here. It says solar powered. Can you take us through this station here?
Yeah, but charging electric vehicles in Africa should not be a problem at all. Because power outages are not every minute.
Exactly.
You almost have power on your network over 90% of the time. You should be able to charge. You cannot say I can't do it because of the 20%, 15-20% time that you might have an outage.
Yeah.
For us, we promote electric vehicle charging, especially supported by renewables, because the sun is all over. And it seems that the only thing we create with this shine is our shadows. We need to use it now to get energy
exactly
for our vehicles, especially considering that we import all the energy that we use in our transport system. We can generate energy, and that is the biggest win case for electric mobility.
Okay.
This is our office, and here you can see our solar-powered EV charging station. And this is a very interesting concept we have used here. It is fully equipped with EV chargers, with smart sockets. This is a very interesting concept we have developed in-house.
Okay.
We have coupled it with a high-voltage battery inverter that can support. This is a hybrid inverter that is making sure that all the energy we charge here, as long as the sun is shining, we're getting a contribution from renewables into our vehicles, as you can see. These are two vehicles. One is my own car, and the other is a taxi driver. And the energy he's buying, a little bit of it is coming from the solar system.
Okay. Nice.
The interesting thing about coupling renewables with solar, even in Kenya where there is an electric mobility tariff, it guarantees you almost a flat price point that is very optimal for business operations. During the day, we can use solar, supplement the grid, and at night, we can use the off-peak electric mobility tariff.
Yeah, in Kenya, there's a time of use tariff for electric mobility.
Absolutely.
It starts at 16 cents peak, and then off-peak, it goes down to 8 cents.
Yes.
Yeah. Sorry. I think in dollars. It's 16 shillings per kilowatt hour.
Per kilowatt, yes.
And then 8 shillings per kilowatt hour.
Yes. And that is 8 shillings is from 10 p.m. to 6 a.m. And the 16 shillings is the rest of the time.
Yeah.
Okay.
Interesting. Yeah. So how many connectors do you have here? This is an AC station.
This is purely an AC station, and it has a total of 8 connectors. We have 4 on each pole. It means that different vehicles are able to charge. So you can see a number of sockets up and down.
Okay.
And so we can charge as many as up to 8 vehicles on this station.
Okay, so tell us about the smart sockets. How do those work?
Smart sockets is our in-house designed solution that enables us to only automate charging using our charge point management system.
Okay.
So all these sockets are connected to our CPMS, and they're meant for taxi drivers and public charging operators who can find a socket out there, and it's only through our system that they can activate that socket to start charging their cars.
Ah.
Yep.
Okay.
Now, what this saves us is it saves us the trouble of having to install the traditional AC chargers out there. So we install an automated, simple solution, IoT solution, that enables charging only through our charge point management.
Via a standard 3-pin socket?
Absolutely.
Okay.
3-pin socket or through an industrial socket, depending on the total current that is being used.
Yeah.
So most of these taxi drivers have to have a portable charger, and they will find a 3-pin plug somewhere out there. They'll plug into it. Nothing will happen. They will connect onto our charging app. We will identify which location they are, and it will be automated for them to utilize.
Ah, interesting.
Yes.
So tell us about this side. This is the DC side now.
This is now the DC side.
Okay.
And here we have different technologies. We are promoters of a technology from Spain called Circ Control, and that is our strong partner. So you could see almost all of these are Circ Control products. And then at the far end, we have 2 products from, one is Setec, and the other one is Teltonica from Lithuania.
Okay.
We pride ourselves with very good quality, high capacity chargers. And here you get from the end, you have a 44 kilowatt double socket, 2222 a commercial AC charger. Then we have the big boy, that is a Circ Control 100 kVN a device, a high voltage charger. Then we have still a high capacity Circ Control charger, another 50 kVA Circ Control device, 80 kVA device there, and then 2 double socket AC chargers and the other. All this is the commercial area.
Oh, this is the commercial area.
Yes.
Okay. How many sites do you have like this in Nairobi?
We have 4 more sites of this nature. We have a site in Westlands. In Westlands area of Nairobi, we have 2 of these sites. Then we have 1 more on the highway, or we call the Thika Road. And then we're building 1 more site in the JK area of this nature.
Ah, okay. And then I see there's a taxi that's just coming, is charging here.
Yes.
So how is that transition going from them moving to traditional gas cars to these electric ones?
Taxi driving electric taxis reduces the cost of transport to approximately 30% of what they use with petrol vehicles. That is just kilometer to kilometer cost of energy. So it's already very attractive to them. The big deal is affording a good quality taxi, and you can see these are good cars. The MG4, of course, already is a premium taxi on our market. We have introduced it. It's a pricey car. But we are only using it, we're putting in the investment ourselves, and we're using it only for corporate and customers who really want that exceptional. And even though the vehicle is expensive, in our model, we're still able to break even. Obviously, when we will get lower import duties and everything else, the business model will be very attractive. For the rest of the taxi drivers, they have to do a lease model. So they pay a specific amount of Kenya shilling per day to use these taxis. They will pick them from any company that has done the capital investment.
Ah, okay. So taxi drivers can lease an EV per day?
Yes, we have approximately 130 taxis.
Wow.
And all of them we are doing a lease model. We are allowing the taxi drivers to pick our vehicles, drive them, charge on our infrastructure, and they have more to take home at the end of the day, as opposed to an internal combustion engine.
How much per kilowatt hour does a taxi operator pay per charging?
On our network, we are charging 45 Kenya shillings, inclusive of taxes.
Inclusive of taxes.
And that is the lowest rate you are getting on the market right now. We've really brought it down so that the taxi driver is able to make his margin at the end of the day.
And how is I know for you to do an investment like this, utilization is important. The higher utilization, the more the business makes sense.
Absolutely.
So from when you started, how have you seen the utilization grow?
It's rapidly increasing. It's rapidly increasing, especially in the commercial segments where there are taxis, there are passenger vehicles, there are public service vehicles. This is rapidly increasing. Of course, the biggest challenge for them is charging infrastructure, which we are being pushed to continue expanding it. But otherwise, yes. Two players have come into the market with compact taxis, and they release them in numbers of 50 units, 70 units. So you can see that those are fleet electrification strategies. So it's moving fast.
And all those fleet operators, they charge on your network as well?
Yes, they charge on our network, but also most of them, every single vehicle has a home charging capability. The beauty of charging on our network is you have this rapid charger, and we also provide a very interesting proposition, a 7.4 kilowatt home charging AC device.
Okay.
Very interesting. Okay. Yeah. It means you are able to get your approximately 25 to 30 kilowatt hour in as little as 5 hours. Home charging.
So which means overnight, you are
fully sold.
Then next morning wake up and you go about your business.
Yes.
Yeah.
And that's where taxi charging becomes sweet, cheap. Because charge as you sleep and ensure that as you start your day, your vehicle is fully charged.
Okay. Interesting.
Yeah.
So tell us more about the labs that you are working on in terms of the backup and also batteries and just also capacitating people to be able to maintain electric vehicles.
So a lot of what we do is competence we have built in-house, but we are only one company, and the possibility to build a lot of this in-house is very difficult. Even for ourselves, we've taken years and years to learn all the entire value stream of electromobility.
Okay.
Remember that I brought the first electric vehicle in Kenya.
Yes.
So this is almost 10 years of doing this over and over. And what do we realize? Even after 10 years, the competence is not there in the field. There are no people who understand the OCP platform. They cannot identify what charging sockets are. So we started a lab to train people on integration of renewables into charging infrastructure, train them on the basics of electric mobility, especially charging infrastructure, configuration and deployment, sizing and deployment, installation, commissioning of electric vehicle chargers. Okay. That's the easy part. The difficult part is dealing with the car. We all like electric vehicles when they're running. When they're not running, what happens? So we started tear down activities, and we've been supported fantastically well with a gentleman from Zimbabwe.
Yes, Taurai.
I
know him well, yeah.
Oh yeah, that guy has done great work here. So he's helped us to do teardowns, and we told him next time you're coming here to do teardown, we'll be doing something else. And he was very happy. And so what is happening in our lab after his foundational work, we are now able to bring in people to do multiple teardowns by themselves. And then once they master that, they're able to go to the next level and the next level. Okay. We are also able to build battery packs directly from the cells. We can do battery assembly, design, assembly. We can design, we can incorporate BMSs and also do proper harnessing of the batteries. So all our electric vehicles can be fitted and diagnosed in our lab.
Oh,
yes.
So if you have a 2011 Nissan Leaf, it has a degraded 24 kilowatt hour battery.
Yes.
You can then take out that battery and build a new pack and give that vehicle a new lease of life.
100 units of this in our fleet.
Okay.
And we are now converting all these Nissan Leafs from 24 kilowatt hour. And originally it was 24. And right now the state of health is around 30-40%. So you are getting maybe 50 kilometers from these units. We are removing all those batteries, training people how to come up with second life application of the used batteries, and then bringing in new cells. The only thing we have to do is get new cells, design the harnesses, and then do the CAN bridge. And then we use the old PMS. They're working fantastic.
And then it's a smooth transition. Because the vehicle itself is still in immaculate shape.
It's still in good condition. The aging is very low. And also the Nissan Leaf is one of the vehicles that you can repair like any other internal combustion engine across Africa. The parts are there. The mechanics already know it. So it's very easy for us to work on that one. Yes. So when we get a 40 kilowatt hour, we're able to get approximately 270 to 350 kilometers, depending on how the driver is economical with the vehicle.
And that range from 200 to 300, it's perfect in terms of their normal daily mileage in the taxi industry.
Absolutely. A taxi driver would have, to be commercially viable, would have to drive between 200 to 300 kilometers, on average 250 kilometers a day. to be able to run their day comfortably well. You also do not want your battery at the end of the day to be at below 10%. So the 270 is the ideal case for a taxi driver within this market.
So 270 kilometers.
270 kilometers, and that is the WLTP.
WLTP. So it's a realistic range.
Realistic range,
okay.
yes. But if you check, and I take screenshots every single morning for my car after I charge, it tells me sometimes 360 kilometers, sometimes I've even seen 380 kilometers. Of course, that is very optimistic.
Okay.
On average, I get around 280 to 300 kilometers from the vehicle. With economy driving for Nissan Leaf.
So I remember you imported the first electric car in Kenya. That was 10 years ago.
Yes.
So in your view, 10 years from now, where do you think the industry will be? Or where do you want it to be in 10 years from now?
Local manufacturing, local skills. Look, we have the energy. Let's put that aside. We have the energy. We should be able to build the energy infrastructure. This is critical.
Yeah.
Then on the vehicle side, depending on how local manufacturing grows, some vehicles, two-wheelers, three-wheelers, and even some four-wheelers should be locally assembled, should be locally designed and locally assembled for different applications. For complex passenger vehicles that have to have some level of luxury or whatever it is, this can come from other markets, but the battery system has to be locally assembled. This is possible. We are already doing battery indigenization of the battery ecosystem. This we have to do. We're already doing that. We have to indigenize both the battery ecosystem and the infrastructure ecosystem.
Okay. Thank you. Thank you, Francis.
Pleasure.
Good to see all the projects and all the progress.
Thank you.
Yeah.
Pleasure.